So hello viewers, welcome again to Advanced Problem Series. This is a problem of work power energy from the book Pathfinder for Olympiad and IIT JEE Physics. This was a request. Problem is see, just look at the statement of the problem. A spring is inserted in a 2 meter long transparent pipe. Let me draw it along with reading the statement. So there is a 2 meter long pipe like this. The length is equal to 2 meter. Transparent pipe held vertically on a floor, and then lower end of the spring and the pipe are glued on the floor. Inner surface of the pipe is frictionless. Ball is dropped. Kinetic energy of ball. Suppose the ball, definitely the ball would be dropped from here, and as per the problem, the spring, suppose the length is not the full length, this one, okay. So it can be seen from the graph actually. See, kinetic energy of the ball K with height from ground. So there, this is height from ground is 2 meter. So if you see from 2 meter till 1.5 meter, okay, so 2 meter, so from 2 meter till 1.5 meter, kinetic energy varies linearly with height h. That means the gain in kinetic energy, loss in potential energy, that means loss in height, proportional to the loss in height. So we have to see where the graph is a straight line. So this is from 2 to 1.5, right? So this part of the graph is a straight line. Straight line means there is no spring, it is only gravity force. So that means the 2 to 1.5, so that is 1.5 meter. So you see what is the relaxed length of the spring. Now see here, when it has fallen down a height of 0.5 meter, right? So that's a height of 0.5 meter, it falls down, it has got a kinetic energy K. How will you find out K? Now this K is equal to so mgh, m into g, 10 into h is 0.5. So h is equal to 0.5. Now what is kinetic energy at that point? See here, when it reaches this, what is the kinetic energy? It is looks like 2.5 joule. So this happens to be 2.5. So that means what is the mass? So the mass happens to be 5 kg, right? Or rather 0.5 kg. The mass happens to be 0.5 kg. See, 2.5 divided by 5. So m, the mass of the ball, is equal to 0.5 kg. Yeah. What else? Determine length of the relaxed spring. So the length of the relaxed spring is equal to 1.5 meter as from the diagram. Stiffness of the spring, so we still don't know stiffness of the spring. And mass of the ball, yes, mass of the ball is equal to 0.5 kg. Yeah. So you have to find out the stiffness of the spring, right? The stiffness of the spring, we can find out stiffness of the spring from the following thing, that see, when the height is 1 meter from ground, when the height is 1 meter from ground, then the ball stops there momentarily. So from the start, say from point 1 to point 2, we can conserve energy. So that means we can write, so the loss in potential energy from 1 to 2, that will be how much? So what is the loss in height? Obviously it's 1 meter. So we can write m, which is 0.5, into g into h, 1, is equal to gain in potential energy of the spring. That means half, because kinetic energy is 0 both at 1 and 2, right? So half k is the spring constant, into what is the compression in the spring, 0.5, right? From the natural length, the compression in the spring is 0.5. See here, that's from this point to this point, right? The compression in the spring is equal to 0.5. Yeah, now so we can find out k from here. So this is 5 into 2 divided by 0.5 square. So this you get 10. So that's k equal to, so k happens to be 40 Newton per meter. Okay, so the force constant of the spring is 40 Newton per meter. Yeah, that's it.